By the time you see bubbling in the paint on the fender of your car, the rust has been going on for probably years. So there are molecular changes that are occurring in our biochemistry. They're called prodromes, basically, to the technical terms of prodrome. And these are patterns that show that you are at greater risk and that you can change that pattern, establish greater resiliency through just, I think, lifestyle. We haven't tested this, but I think exercise, lifestyle, food, supplements, a lot of natural ways of doing things. We could get almost unlimited mileage out of our current, vehicles that we call our bodies.
What if the very systems meant to keep us healthy are the ones keeping us stuck? In this episode of The DNA of Things, I sit down with Dr. Kevin Perrott, a longevity researcher, systems thinker, and founder of OpenCures, whose work lives in the tension between urgent innovation and institutional inertia. Kevin's journey began with personal loss, but what we've uncovered was a global failure, a healthcare model reacted by design, scientific data locked behind silos, and too many people dying while answers exist just out of reach. So in this story, we see it's really about building something different, about making health data personal, systems open, and platforms designed not for control, but for collaboration. So if you've ever wondered what comes after the biotech hype, or how we might finally outpace problems we've inherited, I think you'll very much enjoy this conversation. Let's dive in. Dr. Kevin Perrott is a multifaceted entrepreneur, academic, and health advocate dedicated to transforming longevity science and personalized medicine. Originally a successful business owner, who helped transform a family-owned business called Riverside Honda, my fellow Canadian, as it were, and presenting the largest motorcycle and snowmobile dealership, if I'm not mistaken. However, his life took a pivotal turn after surviving cancer, leading him to focus on research, the underlying causes of aging and age-related diseases. So now, armed with a PhD in biological sciences and medical engineering, he has many things, among them the founder and CEO of OpenCures, a hybrid for-benefit nonprofit model providing individuals with access to cutting-edge scientific tools to measure their health, take control of their data, use personal biobank specimens to accelerate the development of the health technologies they're interested in. So, Dr. Kevin Perrott, welcome to the DNA of Things.
Hey, thank you for having me, Jeremy. It's always good to get the message out there, and I'm glad I might have something interesting to share.
Well, you're absolutely right. It is about getting the message out, and I have a spidey sense, and more than a spidey sense, since we've been, chatting for what feels like years, even though it's probably only been weeks. So really excited to look under the hood in terms of what's going on with OpenCures, but got to learn a little bit more about that story, that the upbringing and the career change that has set you on the frontier, as it were. So yeah, tell us a little bit about that, if you don't mind.
Well, it all started, no, I'm just kidding. So actually, when I was young, I was like 5 years old, our dog died. My mother said, things die. And I was just like completely traumatized. And when you had that mortality, that sense that everything ends. And I go, the dog died. Are you going to die, Mom? And she goes, yes. And that really freaked me out. And since then, I've never really made a friend of this eventual, dissolution of my identity. I've always thought it a bit unfair that we're given this opportunity to experience reality and, all the beautiful things that go along with being alive, only to have it cruelly ripped away from us after a long period of degeneration and suffering. So when I was younger,
5.
Yeah. So when I was quite a bit younger, I was like 5 years old, and our dog died, and my mother told me that yes, indeed, dogs do die, and that she would die. And of course, a mother telling their child that one day they would no longer be there was a bit of a traumatic thing. And I had really never thought about the cruelty of nature when it comes to aging and death, in that, you are brought into the world, you experience life and all the good things about it. and then it's slowly taken away from you. It just seems to me really, really unfair that this is the way of all flesh, so to speak. And I never bought into the idea that aging was a good thing, that death was a good thing. Of course, I put it out of my mind when I was younger, especially, and just learning and enjoying things. But the older I got and the more I saw around me, I got involved in science. I decided I wanted to learn more about the body and biology. I went to university, started learning about biochemistry and physics and how things were actually emergent, and life emerges from the laws of physics into chemistry, into biology. And they were just really fascinating to me there. And I just knew that we could do something about it, that this was a knowledge, iteratively, a knowledge of problem, that the more we knew, the more we could solve the problem of death and aging. And I looked around and people weren't doing much about it. So I put that out of my head for the most part, but philosophically, that's where I was at. And I started working for our family business, which of course everybody needs to make a living. And at that point, it was in the mid 80s, and we were just entering the computer era. So I was kind of responsible for fighting the old school parents about, we do everything by hand. And I was fighting for bringing in accounting systems and inventory control systems, and I taught myself programming. And then when the human genome was beginning to be deciphered in 1999, 2000, I realized from a programming perspective at that point that life was now programmable, that it could be viewed as a program, and that it was just a matter of time that we would be iteratively capable of debugging our own code base or our own problems in order to get at these fundamental aging issues that we all face. And that's when I decided to switch gears a little bit, and I started taking courses in university, immunology, various other things, just to prove my brain still functioned. But then I was provided with an opportunity to understand what true suffering was like by going through an experience with cancer, thyroid cancer. So it was actually a walk in the park in comparison to what an awful lot of other people experience when they go through cancer. But it was enough of a taste of it to realize that what was going on at every moment of every day was basically a nuclear holocaust, killing and creating a whole bunch of suffering at every moment. And I thought, we're not really moving very quickly to handle this level of need and the amount of suffering going on at every moment. If you could convert that into energy, if suffering could have joules attached to it, or it could be like potential energy as a source, which actually then occurred to me, it actually was a source of potential energy. The suffering of individuals is what drives the development of medical technologies. And if there wasn't people suffering, there would be no need for the market, and there would be no need to develop these therapies. And I thought, well, we're not really translating this energy into actually solutions. There seems to be an awful lot of activity going on in development, but it was completely out of proportion with what was actually the need. And how could we develop something faster? And that's where OpenCures sort of came in to play, because if individuals suffering is the whole reason for the development of products and services, but they have no agency, they have no ability to influence speed of development of the market. They're passive and they're recipients of the accepted wisdom of the current system. And there was no way that how could we actually make the consumer of the products actually have influence on their development? And so giving people the power of their own data. So everybody can be empowered with their own health data simply to manage their own health. But at the end of the day, when you get a whole bunch of people who are measuring their health in the same way, you can create an opportunity for people to create data sets that are then very powerful and available for others to use to create the products and services. So that's when OpenCures was sort of the democratization and the decentralization of health technology. And now it's basically we're trying to recreate what the whole medical research system has already, but in the prevention space, because really we're trying to prevent people from becoming sick in the first place. And that takes a lot of data, takes a lot of modeling, takes a lot of it. Now we have AI. 2 years ago, I would have said we don't have a hope in or ice cube's chance in hell of getting any of this done. But with AI, the whole game changed. And I think now we have a much better opportunity for leveraging artificial intelligence to develop cures as quickly as possible. So that in a nutshell is like the beginning and the end. There's a whole bunch of stuff in the middle. I helped co-found a number of nonprofits and a couple of for-profits, and all of these were all just more facets and different attempts to figure out why things were slow. And primarily why things are so slow, again, is because the people who are the most interested in health technologies are not the ones most empowered. So how do we put power into the hands of those individuals who are most interested in the technologies? And that's what OpenCures is meant to do.
You know, sorry, were you going to say something else?
Nope.
Okay. When that kind of finishing statement, very interesting. The ones most interested in health are, let's say, those least empowered or something like that. Recently, I've had a fair number of conversation with folks from the rare disease community. Actually, in particular, I had a guest on the show, Dr. Chris McMaster, who's a Canadian Institute of Health research chair, and he's basically found a way to make it more economically viable, to go after some of these orphan diseases. So, I'm sure you're well aware there are a lot of rare diseases. So if you add them all up, everybody is affected by them, right?
And everybody really needs the same fundamental capacity to measure their health in the same way.
Right. And so there is something universal about the path to, the cure. And I think you're hitting the nail on the head here with, the whole democratization component. But there's no other time than when you're sick. And I think you realize this, and that's what your story really highlights. There's no other time than when you're sick, then health becomes the most valuable, asset, as it were. Or at least that's when you realize, right? Like when we're young and we're invincible, I use the athlete analogy. It's until you get injured, you don't care about getting injured.
There's a meme going around that, you can have 1,000 problems until you have a health problem. Then you only have one problem.
Well, that's right. And so, and so that's the reality. And then you're in it, and then you use the word empowerment. Then you're disempowered to, find the solutions. I was actually just speaking with the, head of the Porphyria Foundation, where, she describes the instance of people trying to get access to their health information, DNA, among that. And they're already frustrated, and they're already tired, and they're already symptomatic, and they don't have the answers. And so, there is that moment where again, that kind of vulnerability is exposed. And, I think there's something there to explore in terms of the importance of the advocate, right? The patient advocate. My wife, for example, when her, dad was diagnosed with blood cancer, he needed advocates. He had advocates in his wife, and
you become dependent. You become dependent on others.
Yeah.
And unfortunately, disease is a complex thing. So you're dependent not just upon others, you're dependent on people with specialized knowledge of your particular condition. So, and there's no competition in that space. You've really only got availability of a few people. Usually they're dictated by your health insurance or by the actual geographical region that you're in and what's available to you. So really it's just a complex, health is complex. There's a lot of risk in there. How do we de-risk a lot of this stuff? And how do we make this knowledge intelligible without having to have all these middlemen, frankly, which are because we don't need this is again, where the advantage of artificial intelligence comes in, is that it can synthesize an awful lot of data and an awful lot of knowledge and come up with solutions. In some cases, the new Gemini model from Google and a number of others have been benchmarked, and they're actually working as good as a human doctor. So it's the complexity of everybody needs healthcare, but we have a very limited number of space of options, and it's very expensive. So, and it's changing fast. Like a human doctor can't really keep up with the amount of information in research. And this is, how do we avail ourselves of the good stuff that's coming out of research as quickly as possible when it takes so long for something to be approved by a medical body for use by a doctor. So it's all about time. It's how do we get the baton of passed from field and domain of expertise to domain of expertise as fast as possible. Now, this is ideally in a research environment when a result is produced on a machine that's paid for by tax dollars. That result should be stored on a central server, and anybody in the whole public, probably potentially, with different layers of visibility. But as soon as a result is generated, it should be made available to everybody across the domain who could potentially use that result in accelerating their own research. The taxpayers are paying for research, and they're paying for, with their suffering as the driver, they're paying for the research with their tax dollars. And it's just poor service. If you had to put all of that into a retail environment where, the satisfaction of the customer dictated how long you would be in business, the current systems would be broke within a very short period of time, simply because they're so poor at translating an awful lot of the resources that they're given into solutions for individuals. And it's not the current system's fault, because the science was never really there and it's just catching up. But what we have now here is a pileup of a tremendous amount of medical information that is valuable, which cannot be communicated or utilized quickly enough by the normal people through the current mechanisms, through the current status quo environment. So this is the challenge to the current environment, is how do they step up and use these new systems? And you spend 8 years getting a degree in medicine, and frankly, you just want to treat people, and with what you don't want to have to retool, continuously. Your brain is meant to accomplish a whole bunch of things and get to a particular level of expertise, and very few want to continue to go through that level of, torture to continue to keep updating themselves, and we just have a lot of information that's just being left on the table, and we need systems. And it all starts with the ability of individuals to access the knowledge themselves, because they're the ones who are the most expert on how they feel. And they are the ones who need to make the effort to make changes in their lives. And this is, for me, it's about prevention. By the time you're ill, we talk about rare diseases, which is, of course, super important, but they are rare. And it's hard to get a constituency large enough from a rare disease cohort. So, but we should be able to help people in their normal day-to-day lives adopt and measure themselves with new technologies so that they can avoid getting a disease as much as possible. And that is kind of the democratization I'm also referring to. Mm-hmm. The problem with rare diseases, and I've worked with an awful lot of these groups, is that they often have gatekeepers as well. Like the different organizations, that the Alzheimer's Society and the Parkinson's Society, these are all people protecting these individuals from, all sorts of different threats. But at the same time they're protecting, they also become a layer of bureaucracy that, has to be worked through. And you can't communicate with an awful lot of people except through these organizations. Anyway, so I think it's important to empower individuals as much as possible.
Yeah.
Then we will get the best solutions.
Yeah. Going to the other extreme, so from rare disease, let's say, to elite high-performing athletes. So I have a call it a proof of concept. So this was work that I'd done previously when providing DNA to high-performance athletes, highest performing humans on the planet, Olympians, some of the best coaches in the world. And, at the end of the day, looking into the molecules of more than 10,000 athletes, a subset of those researched intensely in terms of pairing their biomarker data, if you will, the DNA data, with other specific, call it key performance indicators associated with elite training models. And what was interesting is these were essentially temporal studies done over about a year of following these athletes and their understanding what their training programs were. So what was the strategic and deliberate and intentional stress being applied to them, like how much intensity, density, volume, duration, frequency, et cetera, of different types of training. And then what was their response, using validated card scales from Hooper McKinnon to quantify things like soreness, motivation, injury, willingness to train, rate of perceived exertion, and then organizing this into essentially a model, which when I say model, I mean paradigm. And when I say paradigm, I mean map and not a landscape, but it at least is showing us something such that at the end of the study, when I think about, let's say, following, those athletes and conducting the analysis in the Olympic years back in 2016, and I had a few PhDs on staff, and, we looked at the results, which granted, keep in mind, this was 2016, so it was almost, 10 years ago, before AI, but not really. AI has been around, but not as accessible.
Before ChatGPT, before LLM.
Yeah, let's not use those interchangeably.
Yeah, right.
Yeah. So, but it was interesting because we were able to start to see things like, when athletes who report soreness more often, more frequently, well, there seems to be this, correlation with a decreased ability to absorb vitamin C. Well, that's interesting because that's important for collagen formation and inflammation. Fatigue or mood associated with lower predisposition to absorb vitamin B12, responding to high altitude training, same kind of thing. But many of these different markers, which, I would call this, a meta-analysis, hypothesis outcome to then drive future research on top of this. So a little more than hand waving, but not nothing. And I remember talking to my team and saying, hey, look, how many PhDs is this? And they're like, this is like 12 PhDs, right?
At the level of granularity of the current system, for sure. Yeah.
Back then, yeah. And so, I fast forward now, and I could have used this as like the kind of setup for OpenCures because, you've got your, let's say, early adopters. You've got different, consortiums, let's say, that are interested because, you're not alone in this. And I think that's what's really neat about OpenCures, something that, I had really envisioned, for Athletigen, but it wasn't sophisticated enough to have the language to say what it was. And that is, it's something like, we talked about it at the top of the call. I think you have framed OpenCures as, what is it? Something like hybrid benefit / nonprofit, right?
We need the bottom line is we need to integrate the effects of things that people do with research so that it's iterative, so that when people do something, the effects of that thing that they're doing inform an iterative cycle of research. And unfortunately, just getting a single product or service out on the market is so hard that it usually stops there. But we really need to we are all in the marketplace testing these products that are available, but there's no real centralized data. We should be, all of the companies that are developing wearables, all the companies that have supplements, all the companies that have all of these things, they should all be required to report, the use of the data that they're doing into because they only have one piece of the puzzle. And we need, these are all ad hoc community sponsored trials, even just out in the, this is decentralized science. We are all doing research on our bodies when we go to the gym, when we eat a new food, when we when we do something different. And the results of those different behaviors, if they can be tracked and captured in a logical way, in a consistent way, they are scientifically valid and can be scientifically queried for patterns, which would then lead us to the next level. Everybody's so focused on just accomplishing this level that it's exhausting actually to get anything out the door. But we need to think beyond the first thing that we're doing and saying, okay, so as soon as we have an idea, you almost have to say, okay, let go of it and work on the next idea. And how does your current idea feed into the next idea? And we should always be thinking that. And at the public level too. But, the cycles of politics and all the rest of this are not concerned. There's multiple feedback rhythms going on in research and politics and society, and they don't necessarily sync up, which is why we see a lot of the chaos and, that we have.
Yeah. Yeah. It's like a systems level issue.
Yeah.
You know, something you said there reminds me of a guest that I had on earlier. He's actually in the marketing space, but specifically works with precision medicine, health tech. And his name's company visit. The name of his company was Gene, fellow Canadian, actually. He's based in Toronto. And I really like what how he framed health in general. He said, you know, we believe that health is a value and not a vertical, right?
It's a common law.
Right. And so when you talk about something like, say, these athletes, right? Like, what was the greater motivation? Like, maybe I might have been more clear to say something like, I would like every single human, if I'm serving athletes, let's say, I would like every single human to pursue their maximum potential without getting, you know, a severe injury that they carry with them for the rest of their lives, which a lot of athletes do, right? I'm not saying I'm guaranteeing you medals. I'm just like, if you follow this information, if you learn how to listen to your body, you're going to decrease your chance of getting an injury by tenfold, right? So, because actually, interestingly, side note here is one of the things that I observed was that 75% of these athletes that we were looking at, keep in mind, they're in their mid-20s at this point. So they'd made it through the NCAA, right? They've made it through general training, let's say. 75% of these athletes were enriched for injury protective alleles. Not a surprise, right? Yeah. Hey, I've lost your audio, Kevin. You're muted there.
Yeah.
Yeah. Sorry. Go ahead.
No. Yeah. So they made it through the selection process, just like, you know, 1 in 5 children didn't make it, you know, pre antibiotics, but the ones that did make it had strong immune systems. So you had generations of people. So it's basically evolution in action. So, and we have the selection pressures put on by the actual rigors of the training.
I wanted to just share an idea with you because it just kind of came up organically. We don't have to pull too hard on the thread. Certainly we can pick up the conversation later because I do want to make sure we get a good amount of time to chat about OpenCures, proof of concept, the stuff you're doing in the buck, et cetera. But this idea of the HELA, the HeLa cell lines, right? Those, right? In the lawsuit resolved recently, they're undisclosed amounts. Well, I haven't really shaped this idea or pulled it through, but I start to think about, well, we have like a digital, maybe it's not a cell line, but you have a digital signature that is part of a system that you've opted into, whether you probably forgot.
From a DNA sequence perspective?
Well, maybe, but also just generally, even as a purely behavioral perspective. So I say basically, if there's any product that you're using for free, it's not free. You are the product. Your data is being used
100%.
In the end, get more eyeballs on ads, right? So we actually do have the behavioral targeting technology for behavioral change. What changes are we facilitating? So to me, it feels like it's there. We can do this. And I think these kind of decentralized approaches in these consortiums that, you know, you're kind of banging the drum on. You know.
So I agree, Jeremy. Like, this is the idea, is that individually your data is only applicable to you in a longitudinal fashion.
Right.
It's valuable to you. It's unlikely that anything that is specific to you is going to be, you know, extrapolated to the entire human population, or maybe it is, because we are also very similar. But the real value comes when you aggregate people's data together and you start to see patterns in multiple records, and you can start to see the patterns. With a pattern are the features that come out of aggregates, and it's those features which are not visible from a single individual's data, that are only individual and observable in a data set. And that's really where the power is in helping people measure themselves individually. But if your data participates in the creation of a product or service in an aggregate data set, you should be able to get some value or some recognition for the participation of your data in that creation. And that's currently not available to anybody. So there's no incentive. People don't think that their data has any value because they're never ever rewarded for providing it. And I think that the day is going to come when, you know, like a data bank is truly called a bank because it actually has more value. There's more value in a tangible physical measurement that represents a physical reality for an observable phenomenon than a sort of fictional, what's a dollar worth in a bank account. A dollar doesn't represent anything physical.
Yeah.
Whereas your data is actually something represents something tangible and it's immutable. It's something there.
Well, I think people do still know that their data is worth something, but they're not thinking about it, or they might have forgotten. So, in Canada, for example, we have these, you go to the superstore, that's the grocery store, and you got a President's Choice PC points card, right? Every time you scan that card, when you check out, you get points. Why are you getting points? Because you're sharing your purchase information with them so they can build better economic models to make food more, hopefully, accessible.
You're consenting. Every time, it's a consent. You get points in exchange for your consent, and it has to be a renewable consent. So every time you consent to sharing your data, and ultimately it's about what is your digital identity. So it's your purchases, it's your social media, it's your financial information in your bank account. It's all of your health records. Your health records are really the only solidly personalized set of data that you can claim is inviolably your own. Right. You cannot say that about data that's generated within transactions where you're purchasing something, where the vendor owns part of the data, and you, as a person purchasing, also have a claim on the data. But when you generate your own health data, and it is you, especially if you're paying for it, you own that data, and it is actually a picture of your physical makeup. It is not it's an identity. It's a digital identity for you. And the challenge for the future is how do we manage our digital identities? And it starts with how do we manage our digital health data? It's just one aspect of it. But eventually we will have these digital citizens, which will have the same rights and obligations as our physical identities. But until we have all of our data in a coherent profile, then which can be, controlled by us, the same way we control our bodies and our purchases and everything else, our digital identities will go out there, which will be powered by AI probably. And they will have the same sort of contractual capacities as our physical identities do, and they will also have the same identity. We're just in this evolution of the transference of our physical identity and the projection of our physical identity into the digital world. But it's not, the digital world is not working for us.
Right. Okay. So then enter OpenCures, because we're talking about all the problems, but we're also talking about the opportunities. And, I was struck by how far along you are, with OpenCures. I was struck by the fact that you're not somebody that's just talking about what the problem is, but, you put together a proof of concept. You've got a, let's say, founding community who are active participants, I think, who share your vision, and you're connected into, the forefront of innovation with your collaboration with the Buck Institute, Dr. Nathan Price, who, I've had on the podcast as well, Age of Wellness with Dr. Lee Good. So, you're really in a position to do something here. And so I'd love to learn more about, okay, what have you already done with OpenCures, and what's the, let's say, the paradigm that you're approaching here, or you're proposing that's different? And then, what are we tracking towards in terms of, let's say, a North Star in short and long term?
Well, the North Star is obviously where we need to go, and you have your compass set, and then you say, okay, this is what we need to do. So we ultimately need to empower individuals who need health technologies in order to get those health technologies as quickly as possible. If we let people who are not interested in the health technologies develop them, it will take longer. It's just that. So how do we empower individuals? And so OpenCures is meant to provide access to cutting edge technologies like mass spectroscopy, various other types of, so that you don't need to go to a third party or a health tech care professional, that you become a self-directed researcher. And it's sort of like how you can manage your own finances. You should be able to manage your own healthcare as long as you're competent. And generally, we are very careful how we vet people who are interested in this. And most of what we're actually doing is not risky. We're not doing gene therapies or these kinds of things. We're really helping people measure their health with these technologies. It's like a blood draw or spit into a tube. it's really not that risky. And there should be lots of CROs. 23andMe is a good example. And, getting your DNA sequenced now, it used to cost, the first genome was $6 billion. It's now down to 300. This is the kind of orders of magnitude that we want to give access to individuals as quickly as possible through the OpenCures platform. And, to be honest, most people don't want to know, they don't want to get involved in this kind of scientific, research on their own health. They just want their bodies to run properly and be self-maintaining like they are when they're young. Most of the time, of course, you have athletes who want to become hyper performance and enhance performance, but most people are just interested in not falling apart. And so how do we give people an autopilot? And so we have to create a system that takes the best of breed of all of the science. And now we can do this with AI and LLMs and put that in the pocket of everybody. And that's the North Star and the strategy, but you can't have an LLM that gives you anything worth anything if you don't give it good data. And so this is the main crux of where we are at with the buck and with, any other entity that is trying to do something with AI to become predictive, a prediction of risk, prediction of opportunities, prediction of health. We really do need to create these models. And in order to create the models, we have to have lots and lots of data from many different types of data as well. We've got to do genomic sequencing, proteomic sequencing, metabolomic sequencing. And then, of course, there's all the life history data on top of that, purchases, like you were saying. If we can, so the challenge is in getting in touch with all the different corporations and all the different entities who are actually generating these types of data and bringing them together under one rubric, under one common language. And that is going to take an awful lot of work and an awful lot of agreement from people who are generally not aligned or interested in agreeing with each other. So creating a system where we can help people measure their health at a level of resolution that's scientifically queryable, and showing the world that you can create an end-to-end system where you can benefit the individual, and at the same time, the individual being benefited can contribute their data to the whole. And that current system does not yet work. So bringing all those pieces together, building consortia, I just want to use OpenCures as a clarion call. It's almost just like a symbol of where we want to go. Right now, OpenCures, we provide biobanking. We have a bricks and mortar component where we do blood draws and we do biobanking. We also provide infrared sauna and shockwave therapy. And so we do have some modalities for helping people actually intervene. But we're trying to create a microcosm of the current sort of healthcare system, but in the prevention space. And this is going to take, it's not scalable. It's very difficult to scale this type of a thing. So we need to get automation, and we need AI, and we need individuals, and we need a whole bunch of different companies to come together to create a basic superorganism that's capable of helping people.
Yeah, that was something that really captured my imagination, let's say the last time that we chatted, because that's not the way seemingly that all these different, biomarker quantified self provider companies
they're so busy just working on their piece and survival for each of these small startups or ideas. And then, is first. That's the number one priority, survival. If you actually backtrack to evolution, to when eukaryotic cells, I go back to this analogy an awful lot, is that when eukaryotic cells were only able to produce 6 ATP per glucose molecule, that was their primary source of fuel. They were okay, but they were single-celled. They didn't have enough energy to get together and talk to each other. They had barely enough to survive on, So when they absorbed the bacteria at one point in time and didn't actually eat the bacteria, then the bacteria started producing the 32 ATP. Then suddenly this eukaryotic cell had this amazing amount of extra energy. And in modern day terms, it would be a small startup suddenly getting 10 times its budget donated that it was just for free. So when you have a whole bunch of extra energy around, what do? Well, you start reaching out, you start talking to each other, you start looking for opportunities to work with others. Until you have a lot of extra you are only going to be focused on survival. So what we have now in modern days, you have a whole bunch of companies who are emergent experts at their own field. And now there's this aggregation. And evolution is about aggregation. It's about taking individual things at a lower level of organization, combining them at higher levels of organization. And the same thing is happening in the business world. So you have individual companies developing relationships with each other, create an end-to-end solution to solve the disease and problem, because it's a multifaceted problem. So how do we create the ability? And you have to have a language. When cells were actually picked up on the bacteria, they didn't have cell surface adhesion molecules. They didn't have secretomes of cytokines that were secreting back and forth to communicate to each other. They hadn't even developed the API of life. So what we really do need to do now is, with our computer systems, with AI, is develop the APIs that allow us to automatically, and the agents now, and that's a big focus now of the Price Lab and the Buck and a lot of others, is how do we take advantage of agents, AI, so that we can allow the sort of exchange of information, which without having to have a human in the loop, so to speak, to manage what was really trivial connections and transfers of information. This is because we need to optimize these processes and minimize the time, because right now there's a lot of people doing an awful lot of running around and recreating the wheel, and it doesn't serve the companies and it's not serving the customers. And we just need to have that extra bandwidth so that those entities that do see a better future or are working together creates a bigger marketplace, frankly, and that's how we scale. We can only scale if we bring this complexity to heel and make sure that we're able to handle all of the production of therapies from beginning to end, including their distribution and then the results of their application. So that's the challenge for the future, is how do we automate things and how do we create, bandwidth APIs so that people and entities can talk to each other and just get rid of all of this overhead. There's so much overhead and administrative overhead and the waste. Talk about, I wish the Doge would focus on, creating these standards, that we need to create in order for things to be much more fluid and much more capable of being communicated.
I want to come back to that question at the end when I ask you who needs to hear it. So just a couple of things there, a couple of threads I want to pull on, because I think they're really insightful. And, unless you've studied evolutionary biology or systems biology or microbial ecology, you're not going to appreciate the analogy we shared, which is, this ancient endo-symbiotic event where a eukaryotic cell, so eukaryotic cells are like us, like human cells, animal cells, plant cells, etc. Imagine they're free living and they used to eat these other smaller cells called bacteria. And instead of digesting it one day, let's say by accident or on purpose, depending on what you believe, these bacteria were farmed, and then they, went through a series of, let's just say, genome reduction iterations, such that at first they would have been, say, a pure mutual symbiont, but then became an obligate symbiont insofar as that mitochondria cannot be a free-living bacteria now, or so we don't think. And vice versa, our eukaryotic cells can't live without them unless we want to make 6 ATP versus, the 32. Yeah. I say that story just because I know it all too well. I think I might have shared with you in our previous conversation. I got to do my grad school, my PhD with Fort Dewitt, who actually proved the endosymbiotic theory with Anne Margellis's in it. Yeah. And down the hall from me was Michael Gray, who did it with mitochondria. So Ford did it with plastids and Sinovac.
Yeah. Yes.
So it's a fascinating, let's say just so story as to this aggregation and complexity. And then of course there's the whole, microbiome component of things there. There's more bugs that live in us and on us, and, orders of magnitude more genes. You might argue that we're these kind of walking incubators. My grandmother didn't like that story, so I won't tell that one so often. But because where's the agency at the end of the day, right? But it is a system, right? And we talk about this idea of like paradigms as maps, as not the landscape, but so what is the paradigm that we're looking at? Are we looking at humans as a holobiont, right? So multiple cells and multiple organisms, but then also it's not static in space, it's through time. So you have all these versions of yourself to compare yourself to, and all these populations across the board. So when you think about your, let's just create like a hopeful future, because I know you're in the planning, creative phases of this now. What does a successful consortium look like, 4 years from now for you? What kind of vendors are there? What's the spirit of the operation? What are we seeing? Like, I talked about 12 PhDs in 1 year, and that's just a measure of hopefully the insight that came, but what's the effect that we're seeing? And I liken it back to like your experience with cancer versus a future individual's experience, for example.
Yeah. Well, it was me laying in the hospital bed thinking about the available energy and the suffering of individuals and how it seemed to be not tapped or being converted properly, and thinking that, ultimately what you want is, when you come up with a health challenge, you want a solution in the shortest period of time possible, preferably now. So how do we get that kind of a ecosystem available so that when you do have a problem, it's, they can figure out what it is and they can suggest a solution, and that solution can be created if it doesn't already exist in the shortest period of time possible. And I think that we need models. We need AI. We need models of human biology so that we can take a person's current state of health, plug that into the system and say, it's almost like putting your car up on an exhaust gas analyzer or something like that. We need to be able to do a tricorder, or, we need to get into that level where there's the data of what's going on inside your body. It's easily available. You don't have to have anything amputated or a gallon of blood removed, that sort of thing. So it needs to be quick and easy and done. And then the future cancer patients, you may not even, people won't get cancer. It's about prevention. It's not about waiting for the disease. These things will always happen, but it's about how do we keep the car between the white lines, and prevent it from going in the ditch. Is it possible to almost indefinitely, with tweaks to biochemistry or other types of interventions, address, steering things that go over the line? I think that we haven't tested that hypothesis yet, because we've never been able to measure a person at the level of biochemical pathology. So biochemical pathologies happen long before you get an actual medical diagnosis. It's almost like Canadians will understand easily, anybody who lives in the snow with salt on the road, that by the time you see bubbling in the paint on the fender of your car, the rust has been going on for probably years. So there are molecular changes that are occurring in our biochemistry. They're called prodromes, basically, to the technical terms of prodrome. And these are patterns that show that you are at greater risk, and that you can change that pattern, establish greater resiliency through just, I think, lifestyle. We haven't tested this, but I think exercise, lifestyle, food, supplements, a lot of natural ways of doing things. We could get we don't know, unlimited mileage out of our current, vehicles that we call our bodies. I don't think we really know how many miles we can get if we are properly maintaining it and on top of it using the best tools. And that's how, the car analogy is probably one of the best to think about, because you do have to maintain your car. Everybody thinks that you don't have to maintain your body, that it just maintains itself. Well, no, that's obviously not true. So how do we help our body maintain itself? How do we help our repair systems of our body, autophagy, mitophagy, all of these systems that clean up the garbage in our body can be stimulated far more than they naturally are. We can get in there and we can trigger an awful lot of these processes on a cleanup basis. And who knows how far we could get down, much further we could get down the road in good health if we were able to pull on these big levers of our biology and regeneration, institute regeneration in situ, stimulate the stem cells in situ. We use shockwave here in the office, which, long time ago, maybe not that long ago, it was thought that arthritis and cartilage was not a good regenerative thing. Well, we know now from athletes and racehorses and a whole bunch of people that are undergoing sort of, experimental therapies that you can restore a knee. you can restore a shoulder. And we just don't know how much and to what degree we can do this in the wider population because we're not making those types of technologies readily available. But anyway, so the future is going to be easily non-invasive. It's going to be easily available diagnostics, reproducible data on lifestyle interventions working. And if you measure it, you can manage it. If you don't measure it, you can't manage it. And a lot of people like to be in the Schrodinger's cat box about their health because they don't want to do anything about their health. Change at the thermodynamic level is the hardest thing for a system. You have a system in motion, it tends to stay in motion unless acted upon by an unbalanced force. And that unbalanced force induces change. And change is difficult for everybody, for every system in the universe, in reality. So a lot of people would prefer not to change, even if that change was beneficial for them. That's how bad people view change. So how do we make change automatic, easy? And we do it through gamification. We have to give people dopamine hits for going through the tough part of actually changing their habits. And this is the challenge of working with human psychology, or monkey psychology, as I would call it more, because humans tend to be a little bit more reflective. And how do we deliver on the promise of what we all know is coming, this avalanche of information, so that people can all benefit from it, and including ourselves and our loved ones.
Yeah. Well, I like the analogy of hey, the cure is prevention. And, it kind of reminds me of, I think, what we said more in the beginning, middle of the call was, hey, if I could help people, pursue, their extreme far reaches of human physical capability without getting injured, wouldn't that be cool? And, in the same way, it's okay, great. How can I get you to experience, take that up a level, all of the dimensions of life without getting cancer, or without suffering from these different chronic diseases? And I know that you guys are probably already talking with this, where it's this whole notion of the digital twin. And you look at, say, the All of Us data, these updated, upgraded top 10 polygenic risk scores, and everybody presents, well, we all have our own unique landscape of risk, and, you can't do everything everywhere all at once, but if we learn how to, kind of chip away, introducing, so if I'm at higher risk of Alzheimer's, for example, versus you are higher risk of cancer, my day-to-day living plan is going to be, obviously different. I think health is defined as the same, but how we get there, I think, is very different. And, this whole idea that, there are multiple factors at play here, and that it's not about a single biomarker in isolation as we're talking about. It's like a harmonized profile that we're tracking toward, and you're kind of nudged towards it rather than bombarded with chemotherapy, for example. And so,
if we take nature's approach, right? But if you look at people who live to be over 110, and they thought that analyzing the genomes of these supercentenarians, something would pop out, these magical genes that these supercentenarians must have because they are so outliers to all of the rest of humanity. And what they found was that no, it wasn't. There was maybe one or two genes with some association with extreme longevity, but it was not very strong. And if you look at what it is, it's the contributions of hundreds, if not thousands, of individual alleles, which contribute to the overall stability of the system. And that is, we are reductionist thinkers. We want to find single answers. And we are not systems thinkers, unfortunately. But this is exactly the level that we have to try to use AI at, even though our brains don't naturally operate at that. We can handle what historically, the fact that we can think about multiple things at the same time, or seemingly at the same time, is a miracle. But these AIs are like a new visual tool that can see a set of data, and they can actually visually see the features within the data that our minds would be impossible for us to actually appreciate, because they see the aggregate in whole.
Right.
So, So that I think is where the answer is that you need to analyze these systems. But first, you have to appreciate that the systems are important. And when I was first doing my PhD, and I was thinking, I just think in terms of systems normally. And I think, well, let's measure everything. And as a PhD student, and you go back to your PhD mentor and you say, hey, I just want to measure everything and then we'll figure it out from there. It's kind of like, no, that's like, what is the hypothesis? Yeah. What is the mechanism of action? What is the target? And it's sort of like, that was great because it forced me to think in a way that was very analytical and very reductionist. But you kind of get rid of the forest for the trees when you're actually focusing on that. And the whole system poo-poos, they called them fishing expeditions. But because you didn't have an actual potentially a testable hypothesis, you were in hypothesis generation.
Right.
But I think that what we're seeing now is like an entire shift of the research industry, because now we have tools that generate, terabytes of data, MRIs and, genomics risk scores and things like that. It's almost like a default now is to start thinking in terms of systems, but the status quo is still not about building that system. Right. We need to build the system. You asked me like, what would I like to see in the future for OpenCures? I would like to see OpenCures sort of represent the intelligence which drives the recognition of the importance of different domains of expertise in the creation of products and services and interventions in the shortest period of time possible. So I want a system that rewards people for optimizing, for efficiency. So people get rewarded, actually paid. Oh, you managed to cut the analysis of this thing down from an hour to 5 minutes, or from 10 years to like a week. These are accomplishments which are not rewarded because they are not immediately revenue generating. But, the human genome, as Craig Venter, when he first threatened to patent the human genome, that got the public human genome going. And since then, the human genome, and they're, sadly, they're talking about reducing, the indirects or the available money to research to like 15%, So that's a recent thing that the administration is talking about. But what they don't appreciate is that a lot of the economic, success that the U.S. has had, especially, came from the publication of the human genome. And a lot of these basic research things that came out of basic research are actually paid off their cost many, almost orders of magnitude greater than what the initial cost was. So it's short-sighted for us to short, basic research. And in fact, we should be putting much more money into basic research. I think we should definitely be doing it more intelligently. But what is the driver? So every system has an intent. And if the intent is to make money, the system will, call it quits and go home when the money is made, not when a solution potentially is had. So I would like a system that rewards individuals for accomplishing the goal that the system says it has, which is the creation of products and services and happy customers. I really don't think, I think that a lot of people should get paid for their participation in the creation of the products and services. We need a different intellectual property sort of scheme so that postdocs working at the bench who produce seminal discoveries, even though there may not be the inventor, they should get some reward for the products and services on which that their research participates in. It's just, we need aligned incentives. And I don't think right now our incentives are aligned with what the system needs, which is cures and therapies and ASAP.
Right.
Time is not a variable many people care about.
Right. Well, so look, you've jumped us in to the perspectival questions quite organically. We talked at the beginning, like, well, what is the overarching message? I think you've just said it there quite succinctly. So now the question is who needs to hear that?
The people who need to hear this message are those who are the most inclined to take action. Okay, so Joe Schmo, who isn't thinking about health, is probably not the person who needs to hear this message because they're not even thinking about health. So and what we need is action. We don't need more talk. We don't need more discussion. We need people to actually make a sacrifice, put something in the kitty, And, that's what we really do need. And so those people who have a suffering loved one, who are themselves suffering, or who are very interested in enhancing their health for whatever reason, if it's sports, or they're just normally healthy and they want to avoid disease at every method possible. These are the people who are organically already interested in health. We need to give them a clear clarion call and option for producing. When they produce data, there is a place for it to go. And when it goes to that place, they have some control over it. And so, maybe we should be standing outside of funeral parlors and, helping bereaved people, understand that, there's a whole bunch of different audiences, that need health advice and are open to listening and to hearing it. And the problem is there's a lot of gatekeepers currently who are already involved in that space. And they kind of own the communication channels, they own the expertise. And we really do need to move into the prevention space. But it's almost like, these are all good people. There's nobody in there who's trying to be, that evil about it. But it's sort of like the fossil fuel industry has a vested interest in fossil fuels. They are interested in green energy only as much as they can adopt the green energy and fold it in to their own paradigm. But it's kind of like a leopard can't change its spots. It's just biologically a leopard. So all of its DNA. So we need to create a new system from the ground up whose DNA and define its embryonic development all the way through the developmental stages and say, this is how it's going to grow. This is how it's going to survive. And this is what the adult organization is going to look like. And that is, for adult organization is going to have to include CROs, especially that can generate the data, because without data, we have nothing. So that's the most important thing. Mm-hmm. But beyond that, more importantly, is the relationship with the client, because without the client, there's no need at all.
Right.
So we really have to pay attention to multiple, moving targets, and you need experts in each of these domains. Mm-hmm. So how do we? It's kind of like a Musk level kind of thing. Like he's doing solar panels, he's got the electrical cars, he's got various other technologies which are in different domains, and then he's under control of them, and then he feeds them all into a central thesis. So we need to create, the central thesis here is healthcare, and we need to own the other domains of some sort. We have to have some capacity to control those domains or reward the behavior that we want to see in order to get the overarching goal of developing products and services in the shortest period of time possible. You have to own every aspect of it. You have to have some control over it. Anyhow, so that's fundamentally
what are you advocating for a Muskian overview or integration, or is it a philosophy, or is it a partnership with Elon Musk?
If he was actually interested in this, that would be very, very cool. I think I think a lot of people think AI is just going to come along and solve all these problems organically. I don't think that that's actually going to be the case. Yeah. I think the AI is only as good as the prompt that you're actually using, right, and from the intention. And that's, I guess, the point I was trying to make, that I apparently didn't make it, is that it's an intention. What is the intention behind the system? And if your intention is to get solutions in the shortest period of time possible, well, time is a variable. So how do we create a system that rewards minimization of time? And I think we need an approach that is similar to, that's a system approach. And that's where the analogy to Musk's efforts are, is that we need multiple entities working on multiple domains to come in and feed into a single system.
Right. So I think what you're saying is people who really need to hear this are those motivated for this kind of change and willing to become part of a holistic system that is focused on that system, that main system's output, which is better solutions.
And not just willing to be part of, but balls out, pedal to the metal, all hands on deck, 100,000 people suffering and dying every day, including our parents and ourselves. Time is of the essence. So the only people who are really, really aware of the important, you only have 1,000 problems, unless you have a health problem, then you only have one problem. So the people who get that understand time to solution is the only thing that matters. There are billionaires who would pay $1 billion. They would pay their entire fortunes for a solution if they could get it now. But the problem is there is no system that can actually deliver on anything remotely resemble. I mean, 15 years and $15 billion for a drug, come on. It's absolutely unsustainable and stupid. Everybody knows it's a joke, which is why it doesn't get, the whole health technology development system does not get the attention it should, because everybody's in there at the trough trying to pull out, feed off of the misery and suffering of others and converting it into personal gain, and forgetting that they are on the same chopping block as everybody else. So we need to find people who are aware that they are on the chopping block and that they may be able to get off the chopping block and all their loved ones if they take action, if they provide some level of resources, and if they join with their intelligence and their hearts to actually create a system that would be useful for them and for their loved ones.
If you don't mind, I'll volunteer one more, target interest group, let's just say, into the mix. And it stems on what you just said, loved ones. It's families, children. I mean, I think, that's when speaking just from my perspective, my opinion, that's when I think I've been able to feel true selflessness, is when this vulnerable life comes into the world that I'm responsible for. And, certainly I would love it if my daughter had a PhD in her own body by the time she was 12, right? Like, agency, control, knows where to go, got her own, personal Iron Man Jarvis in her pocket, like that. That to me is like, as a parent, I'm in, right?
I'll flip that a little bit. Why don't we care about our parents?
You say that, and that, that's exactly the other end, where it's like, okay, we're looking at my dad's, long-term care strategy, right? Did it have to be so soon? Does it have to be of the, diminished quality? I mean, it's not terrible, but it's not as good as it could be. So
it's not even long-term care. How can we prevent them from going into long-term care?
Yeah.
And if we have the opportunity to do things for our older loved ones in time for them, which I think we do, absolutely. It's just a lack of will for the most part. I mean, I think within a short period of time, people dying today, people dying in 2-3 years from now, we are at the point where things that people are dying from today will no longer be a problem in 5 to 10 years. Mm-hmm. This is all about speed and time to solution. And we need to just find the people who understand. We're in the end zone on an awful lot of this stuff. Mm-hmm. And we need to and it's not about future generations anymore. It's about this generation and the generation before us. The next generations are almost guaranteed to have a completely different, set of problems than what we currently deal with. Whereas it would sure be nice if we now put our sights on ourselves. And I think that hopefully there is an opening with AI that suddenly people realize the game has changed. And, that's why I'm at the Price Lab. That's why I joined it. And, because this is our chink in the wall. This is the leverage that we could potentially have to make all of this happen. But we need to get the people behind it.
Amazing.
In focus. We need to create a lens that can focus the efforts and desires of everybody in an appropriately it's not non-selfish. It's utterly the most selfish thing to want to stay alive, frankly, and not get degenerative disease. I want to live as long as I can and as long as I want to, frankly. And that's considered selfish, and I don't know why, but I think we have this is one of the most exciting times to live, to be alive in human history. I think have human evolution, let alone history. And we are now within shooting distance of being able to, do something about an ancient adversary called aging and death that we've never had this opportunity before. And how could that possibly not be a driver for so many people? And they're just not hearing it. They just still don't know or think about it in those terms. Anyhow, so what the future is going to look like is going to be very different. And your dog is going to certainly be one of the recipients and beneficiaries of it.
Amazing. So the last question, Kevin, is, so I've already had Nathan Price on. Who would you recommend? Who would you nominate to be a guest on the DNA of Things?
For me, I'm about activism now, and there's lots of great scientists out there. There's one guy, Jean Hebert, who is an advocate for whole body replacement.
Huh.
So one way of avoiding degenerating bodies is actually to do basically a body transplant.
Right.
And and he's one of the guys at ARPA-H as well.
Mm-hmm.
And so I would actually potentially reach out to him. He's got some interesting things to say. And then there's also, how do we get people to think about mortality in its appropriate spot in our lives, and that it is something that we should be striving to avoid. And sometimes there's some psychological stuff, although, it depends on who the audience is and what you want to accomplish with the podcast. But I think that just putting it out there that aging is no longer a guarantee. We don't have to put up with this deterioration of our bodies on schedule.
Mm-hmm.
And we should be looking at enhanced human life health and lifespans of at least a century or more, probably within the next 5 to 10 years. Mm-hmm. And that should be a target.
Amazing. Last question, Dr. Perrott, how can people find you? I know there's OpenCures. I know there's the Buck Institute. Where's the affiliation? Where do people find you?
Yeah, OpenCures website right now is the best place to go. My information's all there. Anybody feel free to reach out. We're trying to build a consortium of the willing who all have something to bring to the table. So come along and join us, and we will make the future together.
Wonderful. Dr. Kevin Perrott, thank you so much for joining me today on the DNA of Things.
My pleasure. Thank you very much, Jeremy, for allowing me to share.
All right. Dr. Kevin Perrott didn't just set out to become a disruptor. In fact, he didn't set out to become a disruptor. He set out to solve a problem for his family. And what emerged was a blueprint for all of us, a model of how science, systems, and stewardship can align when we allow our egos to step aside. Today, OpenCures isn't just a platform, it's a prototype for what the healthcare could be. That is decentralized, data-driven, and deeply human. And now you've heard what's possible in one way of achieving that possibility, and how essentially the story around healthcare could change from reactive to proactive. So what might you do with this insight? Will you wait to see if someone else will fix the system, or will you jump in to be part of the solution? As we saw, Kevin said that if you build it right, you know what? They'll forget your name, but they'll remember what they can now do. And isn't that the best legacy of all? Thanks again for joining the DNA of Things, and we'll speak to you soon.